So here we are at the mechanical part of this chapter. Just gonna do some examples. It's not complicated, so you should be able to follow on fairly easily and extend this to all of the problems in the homework on this section. Call this definitely because what we're doing here is called the definite integral. And definite integral is when we have limits. So the integral from 0 to 1 of this expression, dv. Now, d is going to be whatever variable we happen to be using. So if it's an expression in terms of v, it's going to be dv. If it's in terms of t, it'll be dt. And we say we're doing integration with respect to that variable. So with respect to v here. 2 steps. First, we need to find the antiderivative, excuse me. We need to find the antiderivative. And that's going to be fairly simple with practice. The antiderivative of 1 is v. Antiderivative of negative 8v cubed, right? Remember, we increase the exponent by 1 and then divide by the new exponent. So v to the 4th, and then we divide that by 4. So we end up with negative 2v to the 4th. Same thing here. 7 we raise by 1 to become 8, and then we divide by 8, so we end up with plus 2v to the 8th power. Now, we said this can be any antiderivative, which means that we could have a constant here, but there's no point in having a constant because when we do this subtraction, we'll be canceling out the constant anyway, so we're always just going to use the constant of 0. From 0 to 1, there's nowhere for the 0 and the 1 to live in this part of the expression, so we put that little bracket at the end with the 0 and the 1 just because every step along the way we have to have all of the information for the problem. We can't just remember that it's from 0 to 1. Then we're going to take our 1, our upper limit, and we're going to plug it in there. So we'll get 1 minus 2 plus 2, because 1 to the 4th power and 1 to the 8th power are all just 1. So that there is our f of 1. And then we're going to subtract our f of 0, which is just going to be 0 minus 0 minus 0. And it happens quite frequently that when we plug a 0 in, we get a 0 out, but not always, so be careful. We get 1 minus 2 plus 1 is going to be just 1. Now, I'm not going to do this for time's sake, but remember how to do this in the calculator. You can put that in for y1 and then go back to your screen and do second calc 7. Plug in a 0, enter, plug in a 1, enter, and it will give you the numerical value for the integral. So you can check your work doing that all of the time. Okay, here we can't do this one in this form because we don't have a rule for things that are multiplied together yet. All we have a rule for is number times x to a power, just like we started out when we did derivatives. So what you want to do, if you have anything more complicated than that, is FOIL it out or simplify it in whatever way is appropriate. So here we'll get 3x squared plus 3x minus 2x, and then minus 2 times 1 is minus 2. I think I did that right. Didn't intend to screw it up. Need to do our antiderivative. The antiderivative of 3x squared is going to be x cubed divided by 3, so we'll get just x cubed. Here we need to increase our exponent by 1 and divide by the new exponent. For a constant, just tack an x on there. And going from negative 1 to 2. Now if we put a 2 in there, we're going to get 8 plus 2 squared is 4 divided by 2 is 2, minus 2 times 2 is 4. And then we're going to subtract. It's a good idea to put brackets around this so you remember to distribute the negative. We put a negative 1 in there, we're going to get negative 1. Negative 1 in there will give us plus 1/2. And a negative 1 there will give us plus 2. And how you simplify this is up to you. 8 plus 2 is 10 minus 4 is 6. And then negative 1 plus 1/2 is negative 1/2 plus 2 is 1 1/2. So we're subtracting 1 1/2, and that'll give us 4 1/2 or 4.5 or 9/2, however you want to write that. And again, You can go ahead and graph that and check it using the calculator. Do a couple more real quick. This is another example where we need to simplify first. So you would want to rewrite this as the integral from 0 to 4 of 4 square root of t, which is t to the 1/2 power. And then it'll be minus t to the 1 power plus the 1/2 power would be 3/2 power. You're going to have some fun with your fractional exponents in this section, I believe. Okay, our antiderivative, increase the power by 1, which would be 3/2, then divide by 3/2 or multiply by 2/3. So we'll get 8/3 t to the 3/2 power. And here we're going to increase by 1, so t to the 5/2 power, and then we're going to divide by 5/2, which is multiplying by 2/5 from 0 to 4. Plug the 4 in, we get 8/3 times 4 to the 3/2 power. The way I do 3/2 power is I square root first, take care of the denominator, and then cube. So the square root of 4 is 2, cubed is 8. And then we have 2/5 times 4 to the 5/2 power. The square root of 4 is 2 to the 5th power is 32. So we end up with 64/3. Oh, sorry. We've got to plug in the 0 also, but this is one of those situations where plugging 0 in just gives us 0. So we get 64/3 minus 64/5, which is going to be 128 over 15. Right, get common denominator and subtract. Good to go. Figure out what that is as a decimal. Plug this stuff in the calculator and double check your work. One more, then we'll be done for this one. I said before, the only rule situation we know how to deal with is when we've got a number times x to a power. And that's true except for some very straightforward trig things, right? We know whose derivative this is. This is the derivative of secant. So the antiderivative of that is just going to be secant of t from 0 to pi over 4. So we'll get secant of pi over 4 minus secant of 0. Now secant of pi over 4, cosine of pi over 4 is square root of 2 over 2. Secant would be 1 over that, so that's just going to be the square root of 2. Cosine of 0 is 1. 1 over 1 is 1. So we get square root of 2 minus 1 out of this one, which is approximately 0.414. So when you plug that in the calculator to check, that's the decimal approximation you're looking at. But the exact answer is square root of 2 minus 1. Have fun with these.